This playlist collects together and organizes the individual component modules, which together comprise the lecture covering Alvin Goldman's paper, What is Justified Belief? We'll begin the lecture by talking about how Goldman conceives of his project. What is the goal of his project? What are his aspirations for it? What are the constraints that he places on successful completion of the project? Then we'll turn our attention to recursive definitions. What are recursive definitions and how do they work? And why does Goldman want to structure the paper around finding a base clause for recursive definition for justification? After that, we'll turn our attention to what he spends the remainder of the first half of the paper on. He considers and rejects 4 candidate base clauses for a theory of justification. We'll go through each of them. We'll look at why he rejects them. And then we'll turn our attention to what he spends the remainder of the paper on. He begins by offering a diagnosis of why it is that none of these base clauses is going to work. He'll use that information both to motivate and to formulate his final theory, his reliablest alternative theory of justification. And so we'll go through that, look at each of the iterations that he talks about, and see how he spells out his alternative theory, and see if we can glean some insight from what we discovered there. So let's take a look at those first 3 bullet points. We'll start by going through Goldman's project. We'll compare it to the project from causal theory of knowledge. What are the similarities? What are the differences? Then we'll look at recursive definitions. I'll give you a couple of examples of a recursive definition to help you see how they're supposed to work. And then we'll start looking at those candidate base clauses. We'll look at indubitability, self-evidence, self-presentation, and incorrigibility, looking at each one to see both what the candidate clause is and why it is that Goldman finds them to be inadequate. Let's look then at Goldman's project. Goldman tells us that he is trying to articulate a substantive, and by which I think he means at least necessary and probably sufficient set of conditions that specify in non-epistemic terms when a belief is justified. Now, he sees this project as an attempt at a theoretical definition, one which poses a deeper and more systematic understanding of the thing defined. In addition to that, he continues to work within this framework of analyzing a sentence or sentence form and ordinary usage. Now, I've never quite really understood why Goldman emphasizes this so much, because it's not a particular sentence that we're interested in so much as the statement or proposition that it expresses or the concept that it embodies. Additionally, by talking about analyzing ordinary usage, inevitably he will talk about how ordinary usage is vague. And it's a weird contrast between his discussion about the vagueness of ordinary usage and then his artificially rigorous definitions in this paper. Nevertheless, that is the approach he adopts. He says that his theory will allow that beliefs can be justified without someone's knowing that their belief is justified or possessing the ability to present the reasons for the belief's justification. And so in this way, he will differ dramatically from Bonjour. Remember, Bonjour says the characteristic, the definitive aspect of justification in his mind, in Bonjour's mind, is that connection, that cognitive connection between the knower and the goal of truth. Alvin will say that connection need not be a cognitive connection. It just needs to be there. This makes Alvin an externalist on Bonjour's account, really not even an epistemologist as far as Bonjour is concerned. Despite these externalist tendencies, he's going to engage her in a relatively traditional analytic exercise. He's going to seek to recursively define the truth conditions for the sentence form S's belief in P at time T is justified. Now, I don't know how many people actually utter sentences of this form, but the idea that's embodied by that sentence, the reasons why you might say that that sentence is true, that's what he's really after. Now that we have a sense of Goldman's project, let's shift our attention over to recursive definitions. We can use Bertrand Russell as our mouthpiece here, as he was quite good at this stuff. A recursive definition, sometimes called an inductive definition, is going to have three components to it. First, it has a base or initial definition, a base clause. That gives us the set of initial instances of this kind. Then it's going to have a recursive clause. The recursive clause defines some operations which then can generate either through one instance or through recursive application every other instance of the thing being defined. So it will define all other cases in terms of modifications to cases covered by the base clause. And then the third clause, the closure or limit clause, says those are the only instances of the thing we've just defined. So let's look at some actual cases of recursive definition. Suppose we want to recursively define what it is to be a well-formed formula in propositional logic. We'll start with a base clause. All uppercase letters A through Z are well-formed formulas. Now we've got a set of initial well-formed formulas. We introduce a recursive clause. If phi and psi are well-formed formulas, then tilde phi is a well-formed formula. Phi wedge psi is a well-formed formula. Phi dot psi is a well-formed formula. Phi triple bar psi is a well-formed formula. And phi horseshoe psi is a well-formed formula. Now, if we're being really rigorous, we put our parentheses in there so that we can delimit scope through recursion, but this is just an illustrative example, so I'm not doing a logic class here. Now we've got the mechanisms by which we can generate well-formed formulas of any complexity at all within our formal language. So we introduce a closure clause. All well-formed formulas are generated by recursive application of the first two clauses, and that's it. Let's look at another example, a different kind of example. Let's define natural numbers, our base clause. 1 is a natural number, a recursive clause. If phi is a natural number, then phi plus 1 is a natural number. So we know 1's a natural number, so 1 plus 1 are 2. 2 is a natural number. Okay, well, if 2 is a natural number, then 2 plus 1 is 3. 3 is a natural number. Okay, if 3 is a natural number, and so on. So we can generate an infinitely large class that is the class of natural numbers, recursive applications of our recursion clause on our base clause, generating them out on into infinity. We have a closure clause then. All natural numbers are generated by recursive applications of the first two clauses. So that's how recursive definitions or inductive definitions work. In our next lecture module, we'll talk about why it is that Alvin introduces this notion of recursive definitions and why he imposes this no epistemic terms constraint on solutions to the analysis of justification.